Hello again, my name's Ryan and I'm a technical evangelist at Amazon Web Services. And today's webinar is a masterclass on S3. So the idea behind these masterclasses is that it's a technical deep dive on a particular service. We're going to show you how things work and how to get started on various aspects that you may not be familiar with just by browsing or coming across a service for the first time. The idea being in 45 minutes we can broaden your knowledge with a quick deep dive. So today's subject is Amazon S3. And really the theme is that this is more than just a simple storage service as the name implies. It is a sophisticated, what we'd call a 21st century distributed architecture behind the scenes. It's a highly sophisticated application that ensures that your data is held with 11 nines of durability, and we'll go into how that works and how you can leverage that throughout this webinar. And it's a bedrock architectural component for many applications. Once you start using S3 for storage of all sorts of different assets in your applications or your media applications, you'll find that you never want to go away from it. So let's go down into some detail then on S3. And the first thing is that, of course, S3 is used by many of our customers as a bedrock application component, as I said. And one of the great examples is Spotify. And I'm sure that in our personal lives and maybe where we're at our desks working away with our headphones on, we may stream music from Spotify. Now, Spotify, their assets are stored in S3. And their operations director really talks about the ability for Spotify to scale, to remove the constraints on their storage, not have to do capacity planning on what they would call the most mature large-scale storage platform available today. So there are other examples. If you use Dropbox again is backed by S3. And many applications use S3 in different ways, whether it be for delivering of media, static content via CloudFront, whether it be simply for holding internal assets like code or bootstrapping scripts. They'll be using S3 all over the place. And we're going to go down then into some of the use cases and some of the technical features that enable you to do great things with S3 today. So the idea being really, and if you look at what Spotify do, is they put stuff in S3. And we store it with what we call 11 nines of durability. The durability being the probability of loss of data over a given time period. So that's a significant technical infrastructure behind the scenes to make that happen. Because we have a highly scalable web access to your objects, so you can retrieve your objects at extremely high volumes and rates when you put things into S3. And we're storing those in multiple redundant copies in a region behind the scenes. But it's more than just a simple storage service. So looking at the objects that we have in S3 today, we've just passed 1.3 trillion objects in storage within the S3 platform. And bear in mind that an object can be 1 byte to 5 terabytes in size. We're not talking about small volumes here. There are significant volumes of data. And at peak, we're pushing 835,000 transactions per second reading or writing data from S3. And if you think about how it works, and as I explain in a moment, multiple redundant copies, those transactions fan out behind the scenes because we're storing things multiple times, creating multiple copies of indexes behind the scenes to ensure that we achieve that 11 nines of durability. So what is S3? Okay, it's a web store, not a file system. And I think that'll become apparent as we look through the technical detail as we go through this webinar. It's highly scalable data storage. You don't have any constraints on what you can store. You can store as much as you like. It's fast. It's web sort of speeds. It's economical. You only pay for what you use. And it's highly available and durable in terms of the storage platform behind the scenes. And of course, as everything we do, is accessible via the APIs. And we're going to look at some of those APIs today in this webinar. But one of the things we need to drill down into really to understand how S3 works behind the scenes is this thing that it's a web store, not a file system. And it's a write once, read many platform. So the idea being is that you can, of course, there are plugins out there that enable you to mount S3 as a file system, but it's not designed to work in that way. It's not a block storage device, it's an object storage device. And it has an eventually consistent data model behind the scenes. So let's look at how it works. When you look at S3, S3 is made up of various components spread across a region and the availability zones within an Amazon region. So availability zones being physically distinct data centers or collections of data centers. So when we make a request to S3, we're going through a load balanced infrastructure, hitting S3 web server fleets, and ultimately hitting some storage subsystem to read or write some data. And the storage subsystem, when we write to that, will then make multiple copies within availability zone, but also across a region into alternative availability zones. Shown here is 2, but there can be more than 2 availability zones depending on what region you're looking at. Once we've written data, we then write an index, and in a similar way we write to an index within an availability zone, and we make multiple copies of that index, and then we copy those indexes across the region into other availability zones. So it's by this multiple copies and multiple redundant versions of the data that we achieve the high durability. Now the storage subsystem has constant checksumming of these copies to ensure that they're held with integrity. Now when something fails, and that could be in the load balancing, the web server tier, indexing or storage, then we seamlessly route your request to available infrastructure and available copies of your index and your storage. And likewise, if we were to lose a whole availability zone, again, your requests are swapped to the copies in the availability zone that's still working. So it's these mechanisms, and this is of course a logical conceptual diagram, that achieve 11 nines of durability. But because we're writing multiple copies, then there is a consistency model behind the scenes that you should be aware of. So looking at the eventually consistent model, 3 things. When we write new objects, we will synchronously store your data across multiple facilities before returning success. So when you're writing an object afresh, you achieve what we call read after write consistency. As a general rule, wherever you write S3, you'll get read after write consistency on new objects. So you can be sure that when you've written an object, you then retrieve that object, you'll get that object back. Now, where we differ then is when we update and then perform deletes against objects. So an update, you'll have an eventually consistent model, and same with deletes. So depending on your operation, if you're writing, then you're reading, you could report keys that don't exist, keys being objects. You might return an old key, for example, and deletes then reads, you could still get old data. Now, depending upon the size of the object you write, you might have a more or less lag within that. Now, for most operations and use cases, this won't impact you, but you should be aware that you have an eventually consistent model for updates and deletes to objects within S3. Now, talking about regions, it is a regional service, so data will never leave a region unless you choose to move it. So our regions aren't connected. We don't spread copies of data around different regions around the world to achieve those 11 lines of durability. They're all achieved within an availability zone within a region. Now then, diving down into the technical depth then, when you store something in S3, there are 3 storage classes. And storage classes are a way that you can control the way in which S3 holds your data on your behalf. So the first of those storage classes is what we'd call standard, and this is the default. So when you pop something into S3, it will be stored in a standard storage class mode, where we achieve 11 nines of durability, designed to sustain the concurrent loss of data in 2 facilities. Okay, so this is where we're making the maximum number of copies of your data and doing all the checksumming around that data to ensure integrity of that data. And that comes with a certain price that you can find on the website. But there is an alternative storage class called reduced redundancy storage, or RRS. And effectively what we're doing is making less copies of your data. And it's a lower number of nines in durability, 4 nines for durability, and designed to sustain the loss of data in a single facility. So you can see that we're making less copies, we have to do less work, and as a result, the reduced redundancy storage comes at a lower price point. Now there is a third storage class called Glacier, which is a new storage class for S3, and we'll look into how we use Glacier storage behind the scenes later. But this is where we can put things into long-term cold storage. So it uses a very low-cost storage sub-platform within S3, but you can access these objects through the S3 APIs. The idea being is that you won't retrieve these objects very often, so you can put them into long storage at a very low price point, and you'll only really pay when you retrieve that data. So some ways in which you might use the 3 storage classes is that you'd have objects that you want to have a high durability in standard mode. So this might be a master copy of movie media, for example. You then might move different encodings of that movie, different formats, into reduced redundancy storage, because ultimately if you lost one, you could recreate it, and you can afford to lose it therefore. And then in Glacier, you might then take a digital archive of old movie or broadcasts that you very rarely want to access, but you want to preserve for the future in case you ever need to. So 3 storage classes. Next up, in terms of understanding how S3 works, is namespaces. And namespaces are around the names that you give to objects, the buckets that you store objects in, and keys. So the S3 namespace is globally unique. So the bucket, if you like, the folder or container of your objects, plus the object name, and this is also known as a key in S3, has to be globally unique. So the first thing is when you create a bucket, we'll make a check to see if that bucket name is available. Now bucket names can be anything you like really, and sometimes people would use random generators to name their buckets, or they'll match their bucket names to things like their domain names, and we'll come on to that mode of operation when we look at static website serving. So if you look at the namespace, Amazon S3 global namespace at the top, and then we have buckets, and then within those buckets we have objects in green. So if you think about you being mixed up with every other customer on the platform, you might have people using S3 on the left as a simple bucket to share some documents with colleagues, and they might have in there some photos or some Word documents. And on the right we've got subdomain as a name as a bucket, and at the bottom we've got yourdomain.com. And inside of those we have objects. Now those objects appear to have a folder structure, but they're not. That object and that name, including the slash, the path if you like, is just part of the object name. So an object key is unique within a bucket. An object key can be 1024 bytes long when it's UTF-8 encoded, and it includes those path prefixes that we saw previously. So an object like this is a key. So assets/js, jQuery plugins, jtables.js. For example, that whole string is the object key, and prefixed by the bucket, that will be unique globally. Now, based upon that, if you look at these object keys, and a fictional example of a bucket where I've got my bucket on the left called my new game, and my object keys on the right, S3 will try to automatically partition data across nodes within the subsystems to ensure that we get consistent performance for reads of your objects. And if you look at this example, what I'm really showing here is this is incrementing game IDs. So if this is a gaming website, we've got some photos, some resources, and some text files for each game that we're publishing, for example, on this website. And the game IDs are incrementing each time and storing all of those assets in a single bucket. Now, behind the scenes, S3 will essentially create a partition based upon the first prefix of that object key. So a partition will be my new game/do. Now clearly all objects are then lumped into one partition. Now if one of those games had a particularly high volume against it, you're not going to get consistent performance across all games. So one of the tips and tricks is that you can seed, if you like, that automatic partitioning. You could reverse the game ID in this case. So by simply reversing that ID, what we're doing is creating or enabling S3 to automatically create partitions, in this case /7/8/9, and we're spreading the performance across partitions. So one of the things you can do in terms of throughput optimization is to think about your key naming convention, so you're not coalescing them all on a single prefix. Okay, and there's various different things. You can have a look on the website, give you guidance on some of the different models that you can use to do this and to enable you to search those indexes effectively. Next up on S3, once I've got some data in it, I've understood the consistency model, and I've optimized for performance maybe, is encryption. So S3 enables you to secure data at rest via a simple tick of a box within the console. And server-side encryption really is around then enabling you to take a self-managed, if you like, approach to encrypting your data. You don't have to worry about key management or maintaining a key store. The server-side encryption in S3 is AES 256, so it's a symmetric encryption algorithm, and that we're storing the keys that we encrypt with in S3 as well. So the key store is durable, And because we go through a method of encrypting the key and cycling keys, which I'll explain in a second, it's secure. It's 3-way simultaneous access is required to unencrypt the data. So it's very hard for anyone, and this is an audited process within Amazon, to get hold of your data once it's encrypted. You simply need the object, you'll need the object encryption key, and you need a master key to be able to do an encryption of this data. And you said you can enable this with a simple tick box in the console, but also a simple put header in the request to push your data into S3 will enable server-side encryption. So how does it work? So normally when you put an object into S3, your data is just deposited in a bucket. But with server-side encryption, we will generate a per object key, and we'll encrypt your object as it's placed into S3, and then it will reside in your bucket in encrypted form. And we're generating a random key per object. And we store that object in a bucket in S3, but we're encrypting that key with a master key that is maintained by AWS. And that master key is managed by us and rotated monthly. So we'll re-encrypt and cycle those keys for encrypting your keys. So you can see here you need your data, you need the object key, and you need the master key to be able to unencrypt the data. Now we take care of all of that when you do a get, and we'll pass you back unencrypted data. Now of course this isn't encrypting data at flight, and there's different ways in which you can do that, but this is ensuring that once it's in the subsystem, it's encrypted with that AES 256 key with this key management scheme. So there we go. In the console, when you upload a document, an object, you can simply tick the box, use server-side encryption. And indeed on there, you can also see the use of reduced redundancy storage to change the storage class. Okay, so getting data in, ensuring it's encrypted and so on, all good and well. How do you control who can see what in S3 and who can do what in S3? So we provide you with a set of access controls that enable you to control who does what. So S3 is secure by default. So by default, only you can access the objects that you place within those buckets, and you have to decide what to share and how to share it. And we give you some tools to do that, in terms of policies that you can apply to buckets, access control lists, and IAM integration, identity and access management integration. So let's have a look at those 3 things now. The first, which is IAM, is the overarching, if you like, role-based access controls within AWS. And this gives you fine-grained control over who can do what around S3. So you might administer S3 policies as part of a wider role-based access scheme, and then you can apply a policy, an IAM policy, to users or groups. So shown below, for example, I have an action that enables somebody to put an object into S3, and the resource that people are allowed to do if they're assigned to this group is my bucket and any object within my bucket. So if you like, that's top box is the IAM policy, and then I can assign that policy to users. So Bob and Jane both have that policy assigned to them. They will be enabled to put an object into my bucket. And if I revoke that policy from Jane, or Jane leaves the company and I remove her account, then of course that policy is removed. Now that is functionally equivalent to applying what we call a bucket policy. So you can take a policy and apply it at the bucket level. And again, this gives you fine-grained control. But what this does is essentially allows you to do user restrictions without using IAM. So in this case, we would have the same actions, put object against my bucket, and you've assigned that to a policy on the bucket. But in this case, you'd have to explicitly allow Bob and Jane's AWS user IDs to be able to do such a thing. So you can apply that at that level. Lastly, we have access control lists, or ACLs. And this is coarse-grained control, because this enables you to apply a rule at a bucket or indeed an object level in S3 that would do actions such as read or write, okay, or control the access control policy, read or write the ACL. And you can allow everyone, for example, or you could allow authenticated users, which are other people with S3 accounts, or you can apply specific AWS canonical user IDs. So you could allow Bob or Jane, and you can assign that access control list to a bucket or my object. Now, most commonly, it's the access control list you'll use if you're using something like S3 console in the AWS console, or you're using a third-party FTP type tool that integrates with S3, and you upload an object and you might want to share that with some people. You might set the availability of that object to be read by everyone. In that case, you're applying an access control list on just an object within a bucket. But there's 3 things you need to be aware of and how you might use them. And we'll look at things like bucket policies as I go through some examples in this webinar. And here's a bucket policy. So this is a bucket policy that effectively allows accounts. So there's some fictitious account IDs, canonical account IDs, that enables these people to access or do something within my bucket, the resource applied there. And in case the action is there as a star, so it's a wildcard, they can do anything in my bucket. But I've added an IP address restriction to say that they must come from this particular network, which is the corporate network. So this is effectively Bob and Jane accessing my bucket, but only when they're in the office or on the VPN, for example. Okay, so you can apply that bucket policy, and then all objects within that bucket would be restricted against those rules. So transitions and lifecycle management is another topic. So this is about automating the management of objects within buckets. So objects sprawl can happen, and you might be depositing, for example, logs into a bucket from various different application servers. And you might have a desire that periodically you're cleaning up that bucket so that this isn't growing and growing and growing beyond control. And lifecycle management within S3 lets you do this. So you can do object deletion, so you can control when an object will be automatically deleted from S3. And you can also control object archiving, so you can move objects into Glacier or move it to that other storage class and out of S3 based upon some rules. So Glacier is that long-term durable archive I mentioned before, so effectively being used as a different storage subsystem within S3. And Glacier is designed for long-term cold storage for data is accessed infrequently. So it's the same durability as S3 in terms of 11.9, designed for durability of the archives within Glacier. But it's designed as a write once, read never. And because of that, we can make it very cost effective for high volume data storage within from 1 cent per gigabyte per month. Now you only pay really for accessing the data. So there is a certain free amount of data transfer that you get, but when you go beyond that and you're retrieving lots of data from archives, you'll start incurring the price because we have to go and retrieve that data and make it hot for you. Now we do that in various ways that you can do that via the Glacier API, but when it integrates to S3, it's a particularly elegant model. So I mentioned logs before and expiries. Let's have a look at transitions of life cycles that incorporate deletions and Glacier archive movings. So I might have a series of application logs that are in a bucket and are accessible from S3. And after some period of time, 6 months say, I want those objects to expire and I want them to be deleted. And because there's a simple expiry rule on S3 buckets to enable you to do that. Conversely, we might have transactions. We might have an e-commerce site and we've got transaction audits held in files within S3. Now you want these accessible from S3 for that 6 months period, but after 6 months we want to invoke a transition to Glacier. And then Glacier will take on the storage of that data. The storage class will flip within S3 from standard to Glacier. And after some unspecified period of time, maybe years later, that you wish to retrieve that data and restore that object for access. And you make a request then to restore the data, and you ask for how long that data would be made available to you for you to access before it's removed from S3. Because effectively what we're going to do is to pull the data back from Glacier and hold it in RRS, reduced redundancy storage, for the time that you specify you want that object to be available for. Now it takes 3 to 5 hours for that restoration process to happen, which is standard Glacier restoration time. And then once it's there, it's available in S3 like a normal object until that period elapses. So 3 to 5 hour retrieval time. Now we're assuming you won't access Glacier storage classed objects that often, only when you really need to retrieve maybe what is a single copy of data in your environment. And if you look at the console, you can set a simple lifecycle rule on a bucket. So here I have a rule that is my 10-year archive policy, and it's applying to all objects in my bucket, and it's going to work based upon the days from the creation date of these objects. And I've got two transitions in there. Well, I've got a transition and an expiry rule. So it's going to transition to Glacier 365 days or a year from the object's creation date. And then it's going to expire the objects 10 years from the creation date. So effectively I'll have my object in S3 for a year, and then after which it will move to Glacier storage class, and if I want it back, it will take 3 to 5 hours. But 10 years in, the object's going to be deleted and it won't be available at all. Another way of doing that, and this is a .NET API example. So here I have exactly the same lifecycle rules being defined, and I can see I'm defining a transition after 1 year, so setting my storage class to Glacier after 365 days, and then I'm also setting an expiration on my lifecycle rules after 3,650 days. So I can achieve all the same things that I did simply in the console programmatically. And you might want to consider how you manage the policies around objects in S3, but also how you manage, for example, indexes that you might want to search outside of S3. Because you might want to have queryable databases of all your objects and archives in, pointing to your assets and your keys within S3. That's a very common way of doing things, having a relational data structure, managing a metadata around objects held in S3. Now when you initiate a restore, this is the console view, so you initiate restore and you're specifying the number of days that you want that to be available for. So here I have 7 days. The object will be pulled back, popped into RRS storage and made available for 7 days. Now another way of looking at this is using the REST API. So you'll find that in our documentation we often talk about the REST API, or indeed the XML content that is going to get fired across different SOAP interfaces behind the scenes. And really to note here is that this restore request here is just specifying a number of days against an object in a bucket. And if you want to look into how you assign REST API calls, there's some great documentation online. But it brings an interesting sort of point here, and illustrates quite nicely what you'd achieve via the other SDKs as well, is that there'll be various different response codes, and the REST API clearly is HTTP type response codes. So the responses you'll get from making this call is a 202 accepted. So if this is an object that is in Glacier storage and we haven't requested restoration before, we'll get a 202 accepted and the process will kick off behind the scenes. If I make another request against that object, I'll get a 200 OK, because the object is already being restored. And what that will do is it will simply, or it's already restored I should say, and what this will do is it'll update the number of days that it will be made available in reduced redundancy storage. So it's effectively updating and keeping that object hanging around in S3 for longer. Versus if the restoration is in progress, I'll get a 409 conflict back. So I can, using this for example, periodically check the progress of my restoration, and the other SDKs like Python, Ruby, .NET, Java wrap this up in different ways for you to handle in a more elegant fashion. Another great use case for S3 is serving websites straight from S3 buckets. Now it's a web service, so why not? So why not serve up web content directly from S3? It's highly scalable, it's cost effective, and there's some great tools for managing what gets put in there when. And you can also deal with things like archiving data off using expiry policies if you've got a lot of user generated content, for example, being thrown up behind a content management system, for example, that you might want to back onto S3. So setting a static website hosting with an S3 is really very simple. So you would enable a bucket for website hosting, and you would then enable the default document to be served and an error document. You can put a custom error document. So the top left is setting some default documents. But you can also do redirections. So you might name buckets, and I'm going to show you an example in a second of how we can create buckets that are named the same as our domain names, and how we then marry that together with Route 53 to essentially serve something up directly. When I set a website, we then look at doing a bucket policy as well, because clearly when we're creating a bucket, we want our and serving it as a static website, we want the users and authenticated users to be able to read the objects to return the HTML pages or the image assets or whatever we're hosting. So a bucket policy will enable us to do that. And this is another example of bucket policy, which is public read get object. You can see that name I've given it, which is to allow anyone, the principal AWS star, to do an S3 get object against the resource my bucket, in this case example bucket. So this is a policy you would apply. So you'd flip the bucket to enable static website hosting and then drop this bucket policy on top of the bucket, and then we're ready to go to push some documents into S3. Now it brings in an interesting topic now around the normal addressing versus website addressing of S3 buckets. So S3 buckets, when they're served as a website, have a particular URL form shown at the top. So if I have a bucket, my bucket, and I'm in the region EU West, the URL of my website by default will be mybucket.s3website.eu1.amazonaws.com. Now that's versus normal addressing of buckets, which can take two forms. And we can see down the bottom there that I've either got my S3 region with a path style suffix for bucket object key, or I'd have, if you like, the subdomain type format with bucket name at the start and then my object key at the right there. So be aware that when you do website addressing, you'll get the S3 website in the URL, and it's that you can use then to manage DNS. So this is an example of Route 53 owning the record set for my domain awsexamples.info. So I've got a domain from a provider. I've then created a record set in Route 53, and I've taken the Route 53 name servers and updated my domain provider so that we're pointing at AWS, and Route 53 is now in control of the record set for awsexamples.info. A really quick and easy thing to do that's really, really good for bringing in control of your DNS entries into AWS, because it enables you to do some quite clever things. Now the first of those is to do this. So if I've got a bucket on the bottom right there called AWS examples.info, so that's the name of my bucket that I've given it, and that's the bucket that I'm going to use to pop in my index HTML and my error HTML. On the left I create a second bucket which is www.awsexamples.info, so exactly the same but with the www prefix applied to it. And what I would do then is within S3 on my www bucket is I set a redirect. So I set this to be serving a static website, but I'm going to redirect all requests to my aws.examples.info. So depending on whether I want it one way or the other, I can flip this, but this is going to mean that anyone that types in www.awsexamples.info will be returned awsexamples.info without the root domain there. Then in Route 53, I set up an A record and I use a special alias record. Now in the console, when you do this, you'll see S3 static website sources within Route 53, and you can simply choose the one to apply. And I choose awsexamples.info, which is served as a static website. And then on the flip side, I put another rule. I put a CNAME, and I put a simple CNAME for to redirect www requests into my www bucket, and we can see then we'll complete the cycle. Then when I hit either of those domains, I will then be returned my static website. Another thing that S3 does is object versioning. So because we have unlimited storage in S3, it's possible for us to keep all copies of an object that have ever been uploaded, and we can preserve object histories. Now by selecting at the bucket level the object versioning is enabled, we will preserve all copies of objects. So if you do an update to an object, we will create a new version and keep the old. And it's persistent even if you delete the object. We'll simply create a delete marker for the latest version of the object, and you can simply go back in time to have a look at the old object versions if you so wish. And this is all handled automatically. And it should be noted that once you enable it, you can't turn it off. So I'm going to introduce some APIs now, and one of my favorite SDKs for AWS is Python Botto. So maintained by us. You'll find the Botto libraries on many EC2 instances automatically installed. So a simple case of importing the Botto library, and shown here in my code, I'm connecting to S3. and I'm going to do a get bucket on my bucket, and I'm going to list versions of objects in my bucket with that simple recursion there for loop. And I return then, in this case, I'm printing the version name and the version ID. And I've got my file.txt, and I've got 3 versions, and there's the version ID in text form returned for me. And I can use that version ID then to go and access things. Now it should be said that in the S3 console, with versioning enabled, there's a simple switch, and you can go and look at these versions yourself in the console. But I wanted to illustrate how easy it is to do this stuff via an API. So if I then go and, in this case, go and set my key in my Python language there to key equals bucket.getKey for my file.txt and specify the version ID that I'm looking for, and then I return the contents of my file as a string, because I've uploaded simple files to illustrate the point. The content of my file is this is version 1 of my file. And likewise, I could go and get another version, and in that case, the different version ID returns different content, and I uploaded a second version with this is version 2 of my file. Now subsequently, just so you know, that you can generate URLs for accessing objects within S3. Now you can generate time-bombed URLs, and in the Bosso library it's very simple to do a key.generate and the time in seconds that you want something to be available for. So this is a 10-minute time-bombed URL for an older version. So you can do this for any version of a file, but if you've got older versions, you might want to give up a part of your application is to access older versions of files, maybe for document management. You can pop up a time-bombed URL, pass it around in your application or email it out and so on. Now, once a link has expired on time-bombed URLs, you will be returned a message like this. So the link has expired. So this is accessing that time-bombed URL after the event. And this is something that you can handle in a client application, or that you can simply pass out a URL to an object, email it out, and be sure that after the time that you wanted someone to access, it will be gone. So time-bombed URLs, they're incorporated into that example around using the Python APIs. Now, of course, objects within S3 have metadata associated with them. They have system-generated metadata. And some of that data is like the date that your object was created, the size in bytes of the objects, the checksums. There's flags there. So, for example, server-side encryption, I talked about putting a simple put header. This metadata is a header that is enabling server-side encryption that will turn it on and off. We can clearly see a version ID there, so talking about the object versioning will be returned, and going with that is a delete marker, so that if this is actually a deleted object, then we can see that based upon bucket versioning. We will return the storage class, but we can also do redirects as well for locations, so we might want to override the location of a particular object within S3 when we're serving as a static website and push it into a new object, a new version of a file or a maintenance page or something like that. But you can also store your own metadata. So you can pop up key value pairs into S3, and that will be returned with requests, whether you're managing requests via an SDK, whether you're using a simple REST API and forming up those HTTP headers and bodies. You can get prefixed with XAMZ meta your metadata key in here. So you can put anything you like, and you can drive content around the object or processes around the object without having to respect the bytes in the object itself. So back to that Python API example, a simple key set metadata will set my tag to be equal to the string my metadata, and then I can return that key.getMetadata my tag, and there I'll be returned the string my metadata. Next up is CloudFront. So CloudFront is our global CDN, and CloudFront integrates perfectly with S3. So you can deliver content in S3 buckets from global edge locations at a few clicks of a button. Now you can do download distributions and you can do streaming distributions. So for download, we're talking about maybe static assets like style sheets, JavaScript, images, and so on. You'd have those in a download distribution, and we push those to global edge locations. But you can also set up a global download distribution that will have origins that are EC2 instances mixed and matched with S3 buckets. So that's called dynamic edge location serving. So another topic for another day on these webinar series. But a streaming distribution enables you to serve media files like MP4, H.264 encoded media as an RTMP stream directly from a bucket. So effectively creating a flash media server behind the scenes on top of S3 and giving you a simple endpoint that references an object in an S3 bucket and streams it into your favorite player. So download distribution is a simple case of creating in CloudFront and the console a download distribution, and then various things that you can set. The most obvious and fundamental setting is at the top, which is the origin domain name, which you would just set to be your S3 bucket. And simply clicking in that box will give you a list of your available buckets that you can set as a download distribution. And then there's various other things that you can set on this. So access controls that you might have on your S3 buckets can flow through to edge locations. So you can ensure that you've got signed URLs going out to edge locations. You can do forwarding of cookies or parameter strings that are coming back to maybe dynamic servers as well, and spread out your data across not only S3 but EC2 instances. But you can also pop a CNAME on top of this stuff. So this will generate you a unique URL for a distribution, but you can put your mysite.com on top of this as well and make this a really clean and simple way of publishing assets from S3 directly into existing websites. Streaming, very similar, so choosing streaming on top of a bucket. And again, you would choose the S3 bucket, and here I've got my bucket populated in there. I could again pop a single CNAME on the top. I can turn logging on and off and so on. Now looking at the streaming, or looking at any of those in fact, your content will be served from a whole host of edge locations shown as stars after they've first been accessed. So once they've been requested, there'll be a cache miss at an edge location that people are coming from, and then they'll be served from your S3 bucket. Thereafter, that data will be cached in an edge location for subsequent viewing. And looking at the streaming example, this is an HTML JavaScript snippet which uses the JW player, which is a player that you can get on the internet. And it's essentially setting two sources. Now I've set a download distribution on top of a bucket where I'm serving my JavaScript from, my jwplayer.js. So I have a bucket in my S3 account which has got assets that are static and that I want to be served up from as fast as possible, as close as possible to end users. And there I've got my download distribution URL and then the object key within my S3 bucket, and my object key is jwplayer/jwplayer.js. Likewise, my streaming distribution, I have another bucket with some media in it, some movie files, and here I've got the streaming distribution URL, and then my object name within the S3 bucket that streaming distribution is pointing at, montagemedium.mp4, and a little bit of URL, funny enough, cfx-st to get this stuff to work as part of jwplayer. So that simple HTML snippet, depending on where that is served from or the user is that is rendering that page in that browser, will then pull data from the POP, the edge location closest to them. In my case, it will be coming from London. So a really quick and easy way of creating streaming media into your website. So give it a try. It's really fun and it's really satisfying. Okay, so that's my deep dive masterclass on the topics. Now there are more topics in S3, and we could talk about S3 for days, because it really is, as Werner Vogels, our CTO, talks about it being the 10th wonder of the world. But the idea really around it, let's summarize it, is to stop doing this sort of stuff. So stop thinking about capacity planning on storage because you don't have to with S3. Stop worrying about the management of storage devices, worrying about backing up a backup that you might have on a storage system in your office or your data center, and worrying about fixing broken disk drives when they break, because all of that stuff is wrapped up in S3 and we do it for you. And because you can stop worrying about those things, you can start doing some of these. And these are some of the sort of broad-ranging use cases that use some of the features I've talked about. Now, clearly I've talked about SDKs, so you can incorporate S3 into your application backends yourself. Or you can download, if you're using maybe a content management system like WordPress, you can download plugins which move everything off the file system into S3, essentially as a place to store up user-generated content. So that method is being used all over the place by different applications. Bootstrapping EC2 instances, and when we look at the EC2 Masterclass that's coming up in a few weeks, we'll talk extensively about bootstrapping. You can use S3 as a place to store your scripts, that your EC2 instances, when startup, go and pull these things and assets from S3 and set themselves up in a way that enables them to do something intelligent. We have Storage Gateway and other third-party tools that might enable you to take an Oracle database, snapshot it automatically in your data centers, and push that up into S3, and then regenerate databases in the cloud. So Storage Gateway, a great way of doing that, and it all backed on S3. You can store your application logs in S3, unlimited storage, and then you can start consuming those with Elastic MapReduce to process vast volumes of data. We've looked at serving web content, and of course S3 is a great platform for doing document sharing with all the access control versioning you put around it, and of course the popular Dropbox is indeed built upon S3 itself. So hopefully you found some information in this webinar that you didn't know before, and it's gone and expanded your knowledge a little bit more. And of course, as always, aws.amazon.com. Have a look around there. Have a look at the future webinar series that we're doing. Sign up and get cracking and using the services.